So, this particular lecture is on actuation. So, based on the readings of the sensor, we have already seen different types of sensors in the previous lecture, and based on the readings of these different types of sensors, some action might be required to be taken, and that is done by actuators. These actuators basically perform certain actions on the environment, on another system, on a device, and so on. So, there are different examples of actuators. I am going to show you different types of actuators very shortly, but these actuators, they can have principles, working principles, which are based on electronics, then electrical, then mechanical systems, and so on. So, they basically use some kind of control behavior, some control signals are sent. Okay. So, this is how these actuators they perform. We are going to go through the different mechanisms behind the functioning of these actuators in this particular lecture. Before we proceed, I wanted to show you at the outset some of these actuators that can be used. So, here is an example of a sample actuator, which is known as the relay switch. So, this relay switch, it is an electromechanical switch. It is an electromechanical switch which can be used to switch between AC and DC, for instance, or different other things can be performed. So, the sensor networks, the sensor nodes, they typically operate in DC, and based on the sensed value, maybe you want to switch off the electricity in your room or at your home based on maybe something, maybe fire has been detected by the sensor network, then you want to do something, you want to turn off the power in your home. So, that is AC, that operates on AC, right. So, this particular switch, this electromechanical switch, will basically turn off the AC, the power supply at your home. This can help in doing it. So, this is an example. This is known as the relay. There is another one which is the solenoid valve, and this basically can help in controlling the flow of liquid. So, you have an input, you have an output. So, we have an input, we have an output, and this solenoid valve, if we open it, so what we can see over here is what is inside. So, so water can flow in, and depending on the conditions, this valve is going to either allow the water to flow out, or it is going to stop, it is not going to allow. So, this is another actuator. Like this, there are different actuators that are available for use in IoT. So, having seen some real life actuators, let us try to understand the basic principles of actuators, but before that, let us go through some of the basics. So, an actuator is a component of a machine or a system that moves or controls the mechanism of the system, So, typically these actuators are based on some control system. These control systems, they act on the environment. So, an actuator basically requires some kind of a control signal and a source of energy for their functioning. So, typically, I said that control signals are required for the actuators. So, when these actuators receive a control signal, they respond by converting that energy into mechanical motion. Mechanically something is going to be done. This is an example, of course. So, they convert that electrical signal, some control signal, into mechanical motion, and that control system can be simple, which can be based on some mechanical or electronic system, or it can be software based like a printer driver, a robot control system, a human, or any other input. So, what we have are three types of actuators. One is this electric based actuators, we have these pressure based actuators and we have these mechanical based actuators. Each of these they send control signals, and based on that the actuation is going to be performed. So, we have hydraulic actuators, pneumatic actuators, electrical actuators, thermal actuators, magnetic actuators and mechanical actuators. So, as this name suggests, these hydraulic actuators consist of a cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion is converted to linear, rotary or oscillatory motion. So, basically when some fluid passes through, so then that motion is converted to some linear motion or some oscillatory motion or rotary motion. And since liquids are nearly impossible to compress, most of the hydraulic actuators basically exert considerable force. So, that is the reason why liquid based actuators are typically used, so these are quite popular because of this particular reason. On the left hand side, we see an example of an hydraulic actuator which is based on the use of oil. So, in this particular cylinder, oil will be there, and then when you apply pressure on it, it is going to give an output based on which there can be some linear motion or some oscillatory motion or rotatory motion or whatever that can be performed. So, here on the right hand side, we see over here a figure which shows an hydraulic actuator based radial engine. So, as we can see over here, this animation is quite it is quite explanatory. So, as we can see over here, so liquid goes inside, and when you synchronize the liquid going inside from these different directions, then what happens is you can emulate a rotatory motion like this. So, this basically can help in the functioning of an engine. So, it can give a rotatory motion in this manner. So, these were the hydraulic actuators. Pneumatic actuator, pneumatic means air based. A pneumatic actuator basically converts the energy formed by vacuum or compressed air at high pressure into either linear or rotatory motion. So, the rack and pinion actuators are typically the pneumatic actuators, and these are used for valve controls of water pipes. Pneumatic actuators basically exert lot of force, and for example, the pneumatic brakes can be very responsive to small changes in pressure that are applied by the driver. So, pneumatic brakes are quite common in different like trucks etc., they use pneumatic brakes. So, hydraulic brakes are more common in cars. In trucks, the pneumatic brakes are quite common. So, these pneumatic brakes, the advantage is that they are very responsive to small changes. If the brake is pressed little bit, they act quite fast. This is an advantage of these pneumatic actuators. So, basically what happens is the pressure that is put on the brake, that is converted into force pretty fast. So, this is one of the advantages of these pneumatic sensors. So, here is a figure of a pneumatic sensor. When you apply pressure over here, so this crankshaft or this shaft will move, and this is an example of a pneumatic actuator. So, basically this is a figure which shows an air pump acting as a pneumatic actuator. Then we have seen hydraulic actuators, we have seen pneumatic actuators, and then we have the electric actuators. An electric actuator is generally powered by a motor that converts electrical energy into mechanical torque. So, this electrical energy is used to actuate the equipment such as the solenoid valve, which control the flow of water in pipes in response to electrical signals. And this is what I was showing you at the outset. I showed you one of the actuators, the solenoid valve I had shown you, and this basically works on the principle of electrical actuator. So, on the left hand side is a figure showing a motor drive based rotary actuator. Okay. So, basically so what happens is this basically the electrical signal over here will help in moving this, and so it is going to give a rotary motion of this particular part. So, this is an example of a motor drive based rotary actuator. Here in this particular animation, what you see is the functioning of an electric bell. An electric bell is an example of a solenoid based actuator, So, as you can see over here, once the bell is pressed, then the connectivity is established, and then the electromagnetic field is generated, due to which the bell sounds, and this is the way in which solenoid based electric bells function. So, these are two examples of electrical actuators. Then we can have thermal or magnetic actuators, which can so thermal or magnetic actuators, these can be actuated by applying thermal or magnetic energy, and typically they are very popular because of being that they are very compact, lightweight, economical, and with high power density. So, these actuators use shape memory materials or shape memory alloys, SMAs, and this is very popular at present. So, this is how it works. So, this is an example of an SMA based piezo motor. So, as you can see over here, these are the different steps in which it works. So, these are the two metal strips, and when when the energy is passed through it, they bend, and when they bend, they basically move this red and white strip mechanically. So, this basically acts as an actuator. So, this is like a joint metal bar, and when you, so this is like this, sorry. So, when you hit this metal bar, this is an alloy bar consisting of two metal strips, and so the property is that when you hit it, then it is going to bend, and when it bends, it is going to move this particular strip in this manner. So, the different steps are shown over here, and this is quite evident, this is quite explanatory from these steps. So, this is an example of a coil gun, which basically works on the principle of magnetic actuation. So, this is also quite explanatory. So, this coil gun, so basically electromagnetic field is generated, and then again it is pushed and so on, and this is how. So, basically the functioning of the hyperloops, at present people are talking about hyperloops, right. So, presenting the functioning of the hyperloops are also based on this particular principle. Then we have these mechanical actuators, which basically converts rotatory motion into linear motion to execute some movements. So, this basically involves these gears, pinions, rails, pulleys, chains, and other devices to operate. So, rack and pinion is an example of a mechanical actuator. The figure shows it, and it is quite explanatory from this. So, as it moves, basically this also moves. So, a crankshaft is another example of a mechanical actuator. So, this is how the crankshaft works. So, as this thing moves in this manner, so this gives this one a mechanical motion, a rotatory motion. There are different soft actuators which are actually polymer based and are designed to handle fragile objects like fruit harvesting in agriculture, or in biomedicine, handling internal organs of human beings, and typically these are used in robotics. So, soft actuators are also quite popular, and these basically use something known as the SMPs, the shape memory polymers, which are actually polymers, and the behavior of the polymers will change depending on the stimuli. The stimuli for these polymers are the light, electrical signals, magnetic signals, heat, pH, etc., etc. They have different properties. These polymers, they behave differently due to these different variations in these physical properties. Then we have the light activated polymers. These polymers basically get activated through light stimuli, and these are also quite popular. So, what we have seen are different actuators, their actuation principles, and different diagrams and figures of them, and at the outset we have already seen some real actuators that can be used for building IoT based systems. Thank you.